Hello everyone and welcome to day 53 of 100 Days of Code in IoT Challenge. I'm Thomas and this is the channel that educates you on IoT and web development by showing how to build projects step by step. Today I'm going to continue working on a snake game project and I'm going to implement a score points system. Let's get started. Okay, right. So here's my Visual Studio Code with the latest implementation of the snake game from yesterday. Okay, where we have almost everything done and working. The only piece of functionality that is missing is the score system, right? So we're not tracking the number of pieces of food that snake has eaten already, right? We don't have a score. We don't display it on the screen. Even at the very end, when the game is over, essentially, when snake hits itself or the wall, I just display game over. I would like to also display the score, something like, your score is something blah, 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 right? And that's the goal, as I mentioned before, that's the goal for today, for today's exercise. That's the goal. And to achieve that goal, I try to write as little code as possible, right? So the focus is to just finish it with the least possible effort, have the game finished. And then in the next videos, I can do some extra work, just polishing it and maybe adding some extra functionality to it, right? But yeah, today, the ultimate goal is to make this whole game working, okay? So yeah, so the score points. To track score points, I need a variable. I'm gonna call it score and set it to 0, right? So yeah, I got a variable. But now I need to identify the place, a function, an event, something happening in the code that should increase the score, right? We already know what it is. Because if you look at the snake game, how that works, right? How it worked on Nokia, basically the point has been scored when snake eaten the food, okay? So you eat the food and this is the moment where, apart from choosing another random location for the new piece of food, right? For the pixel of food to appear somewhere else, the point is scored the same time, okay? And we've got this handle. That's something I handled recently. And it's in the form of an event, if you remember that. On food added, right? That's the callback function that if you pass to the constructor is going to be called with the exact coordinates of the new food, right? The coordinates of the new piece of food, that green food pixel. But just the fact of calling that function indicates that the point has been scored, the food has been eaten. So it's gonna be as simple as just going back to that place, right? Where the game is constructed, we draw that green pixel of food whenever snake eaten the previous one. And that's also going to be the place. See, it's very close to where I declared that variable and assigned it a value. And that's going to be the place where we just increase that value, right? We increase it here. However, I'm just looking and I think, yeah, I'm gonna have to change that score to -1. And I tell you why. So when you construct the game, you pass that callback to the constructor. And when the game is initialized, when we call start, that's the first time when that callback is gonna be executed. Let me prove you. So if you look at the game, start, we have add snake, add wall, add food. Add food executes on food added, which is going to essentially execute this function at the very beginning of the game, even before the point has been scored, right? That's the very beginning. That's the first piece of food appearing on the screen. We don't want to score the point at that time, right? When we just initialize the game, we don't want to score the point. So if I start from -1, that's just gonna change to 0. And from there, the game just gonna continue and every next piece of food eaten by the snake is gonna be scored normally as a point. So that's why -1 for the score here, right? So yeah, so this is as simple as that for keeping track of the score. But now I need to display the information, right? Display the information, what was the score that you managed to achieve. And the first place to do that would be when the game is over, right? When the game is over, we can just display it. And I'm just thinking what I could do is to, yeah, I can just print it on the screen after game over. So essentially we need to print the text, something like your score, colon, the actual score, just below the game over, right? Which is gonna be just a bit tricky because game over, that is set to the cursor of 0 and height divided by 3. We need your score to be below game over. So we need height divided by 3 plus something, right? Remember, lower you go in the screen, the height increases. So basically, I'm gonna have to set the cursor to height divided by 3 plus the size of the height of the text size of the game over, which is going to be, you see, size 2 is 12 by 16, so it's 16 of height. So maybe just to be on the safe side, I'm gonna put 24. The text size for the score can be 1. And then we can just, can we print it? Oh yeah, I'm gonna have to, this is gonna be a C string. So I'm gonna have to declare something like score text, char array, sprintf, and there's gonna be score text. And we have something like your score is this. And the D is gonna be replaced with the actual score, right? TFT print, and that's just gonna be score text. Yeah, that's how this is done. Okay, so set text 1. Yeah, so yeah, this block of code essentially is going to display your score and the actual score, right? The value of the score variable just below the game over, right? It's not exactly below. We added 8 extra pixels, so there's gonna be a 8 pixels gap between game over and your score. So that's essentially what happens in here, right? Cool. So yeah, so that's the simplest functionality for tracking the score, and I think with the code that we've got right now, I can just deploy it. Yeah, let's give it a go. I will deploy it, and after that, I'm gonna show you how to improve it, how to have a live score appearing on the screen, because that's essentially gonna be the next step. I know this is the simplest. The next functionality is not the simplest, but this is gonna resemble how the original Nokia game worked. So yeah, but yeah, let's test out this solution right now. Okay, deployed, and let me try to score some points. Okay, and now I'm gonna hit the wall. And there we go. Your score 3. Right, so we can see it on the screen. And now the game restarts and we can try again. But yeah, essentially it works. Okay, cool. And now let me show you how to display the score in the real time, okay? To display the score in the real time, but to explain this, I'm gonna have to show you that on the spreadsheet, right? On the spreadsheet, because yeah, as you can see here, this is a good example of the snake, right? We've got the wall at the edge of the screen, and here is the snake that is about to eat the food, okay? And yeah, if you think about displaying the information on the screen, the live score, the problem with what we've got at the moment is there is no space to do that, okay? There is no space to do that. So, so to display it, we would have to shift it a little bit, right? Like leave some empty space at the top, ideally, at the top, right? In order to do this, first step would be to decrease the height of this snake field array. Okay, decrease the height. And that's something I'm gonna do. So if you look at the code, the height is really what we defined in this constant, right? It's 128. And because we would like to display a score points on the top of the screen, what we're gonna have to do is to decrease that, and I'm gonna decrease it by 8. Why by 8, not other value, is due to the fact that if you set the text size to 1, the height of that text is going to be 8 pixels, right? As you can see here, 1 is default, and that is 6 of width by 8 of height. And that's gonna be the height which I'm going to steal from the top of the screen, right? And to steal that, it's just about changing height from 128 to 120. That's the first step. And the second step is gonna be to shift. That's gonna be to shift the Y coordinate. What do I mean by shift? Before I show you, let me, on this representation of the snake field, let me demonstrate how that field is gonna look like if you just decrease the height without any other changes, right? So something I've just done. If we compile and upload the sketch to the board right now, what we're going to see on the screen is something like that. It's all gonna work. All the collision checks, food eating, even, you know, the score that we keep track of in the memory and that is shown up when the game is over, this is all gonna work. The only difference to the previous code, to the one I've just tested, is going to be this gap, right? This empty space at the bottom of the screen. This is simply because by decrease the height, the screen in the memory, the snake field, ends on 120, not 128. So we'll see 8 pixels, not 4 like here. It's gonna be actually 8 pixels empty, like a big rectangle. Width is gonna be width of the screen, which is 160, and height is gonna be 8. Right, so we'll have a space on the bottom of the screen. And now to move that space to the top instead, we're gonna have to do a shift of Y. So we're gonna have to add all the pixels that we draw. We're gonna have to add that shift that we have. Our shift is 8 in the code, but here this is not really one-to-one representation. If you look at this, right, we just have a 23 pixels of width, and like at the moment it's 19, but it can be up to 22 pixels of height. But still, I think with this example, I can roughly explain what is going to happen. So yeah, let me just add another column over here, and let's say this Y coordinate is now going to be a representation of the screen. So that is YS. That is gonna be YS, and that is the screen, right? So X is gonna stay the same regardless of whether it's screen in the memory or the memory. The memory is gonna be the second one in here, right? That's the screen, that's the memory. And X is just gonna be the same for both, because we're not really changing X. X stays the same, no matter how much of a space you add at the top or at the bottom, the X coordinate is gonna stay the same for the screen and for the memory, right? But yeah, let me show you what do I mean by screen and memory, because that might be a bit confusing. So by the memory, I mean the location of the field element in the field array, right? In the game struct. That is a two-dimensional array, right? So with the first dimension is X, the second dimension is Y. So that's the representation of the memory. And this is that coordinate which I haven't added yet. And then what is the representation on the screen? What is the coordinate on the screen is essentially what we draw with TFT, right? So draw pixels we draw X and Y usually, and that is 1 to 1. It used to be 1 to 1, but now because we want to, take up some space on the top, we're gonna have to change that. There's gonna be the shift between what is in the memory and what is on the screen, right? It used to be 1 to 1, and you can actually see that where we draw entire thing, right? We draw the game field. This is drawing the game field with everything except for the food. So we see that function is called for every single pixel on the game field, and we've got the X and Y coordinates, and we essentially draw the same. We draw this pixel with the same coordinates. Okay, so that was 1 to 1, and that's also happening for the food. That's also happening for the food. You see the green one is also 1 to 1. Now, because we're taking up some space, and that's ultimately gonna be on the top, there's gonna be a difference between the screen and the memory, right? So the screen is gonna be like this, right? That's gonna show us the screen, but because we take up some space from the screen, the memory now is gonna be smaller, essentially, right? On the width, and I've already done it. I've already done it by decreasing 128 by 8, so we have 120, right? So memory is smaller now, it's not as big as the screen. Let me show you how this is gonna look like. So let's see, we take up, here is 4 pixels. We're gonna take up 8, but let's just take a 4, for the sake of an example, right? So I'm gonna move this empty space from here. I'm just gonna move it to here. So let's just do it on 4, right? On 4, this one is going to go like here because we want to keep the bottom. So that's gonna end up at the bottom edge, and only the top is what we take in from the screen. Okay, that's what we take in from the screen. Okay, cool. So yeah, so this is again the screen coordinate, screen 1 Y coordinate, and as you can see, it starts at 4. There is nothing at 3, 2, 1 or 0. It starts on 4, and X in this case doesn't matter again, right? We're just shifting the Y. And now how this is gonna look like in the memory, because we shrink the memory, this is where it starts. In this example, it's just 4 pixels that I took. In the code, it's 8 pixels. So imagine there is 8 pixels in here, essentially, right? But you see there is a shift. There is a difference between the screen coordinate and the memory coordinate, right? So what is 0, 0 as the memory coordinate is actually 0, 4, right? For the screen coordinate. And this is why I'm going to add that difference that we have between the maximum height of the screen and the height that I've taken to have an empty space for the score is gonna be the exact value that I'm gonna add to every single place where I draw the pixel. And for that, I'm just actually going to define something like a height shift constant, okay? So we'll have something like that. Maybe later on, I will have something that auto-calculates everything, but for now, let's just do it with the constants. So height shift is 8. That's the space that I've taken from the screen to display the score in the real time. And what is good about that approach is that I don't really have to modify anything in the game or Snake. That's all gonna stay as it is. Collision checks, the food appearing on the screen, and so on. This is all gonna stay as it is. The only places I'm interested in, all the places I'm interested in is where the pixel is drawn on the screen, and specifically the Y coordinate that I have to increase by the shift, the height shift, right? So this is the first place. This is where the foot is drawn on the screen. So that's just, gonna be that difference covered again, right? So let's say we got something from the memory, we got a new place for the foot, and let's say the coordinates, the random ones generated is gonna be 12 for the X, and let's say it's 10 for the Y. It's going to be displayed at the position of 12 as an x coordinate and 14, right? That's shift. 14, which is in the code is gonna be 18, remember that. And that is why I've got y plus height shift, right? Shift is 8, it's gonna be added to the existing y coordinate. Right, so that's one place. Now the second place is over here. This is where we draw the game field. And finally, we've got these bits of code responsible for the moving the snake, right? So drawing the pixel in front of the snake and removing one from the tail. So yeah, again, that's gonna be the shift on the y coordinate. Again, it's just on this one, right? So as long as we make sure we just shifting it on TFT screen and it's only about the y coordinate, all the calculations, whole game essentially, the whole game logic essentially is gonna stay the same, okay? So that's it. It's just about that. You just need to add this shift value to all the places where the pixel is drawn and just to the y coordinate. Okay, so now we're gonna have an empty space, something like I showed you on the spreadsheet. But now with that piece of the screen, right, empty, we would like to display a score over there, right? I would like to display a score in the real time. So where that would happen is essentially where the score is incremented, right? So I increment the score and right after that, I would like to display it. So that'll be pretty straightforward if you think about that. I just need to set cursor to 0, 0 because that's the top left of the screen. Then I want to set text size to 1. The color of the text, set text color should be white. So that'll be white. And finally, I can essentially just print it. So I will do print and score. I don't need to do your score because that is already covered for the game over. You still be able to see what was your score, but that's just, you know, this extra bit to make this game also like, you know, more kind of resembling the original game. So we'll see the score in the top left corner, right? So that prints it out, but it's not everything because think about that. That's gonna be updated every time Snake eats the piece of food, right? And because we're not really clearing anything in that position of the screen, you know, once the score changes from 0 to 1, we won't really see 1, but 1 over 0. So it's gonna mess it up. And to prevent this sort of situation, what I have to do is just fill a rectangle. So I'm gonna draw a black rectangle just to clear that piece of the screen that I've taken. And that's essentially gonna start from point 0, 0. And that's gonna finish on, I think the next one is actually, let me check that. Can I actually check it? No. Nice. Yeah, I think the next one should be width. And the last one, finally, that's gonna be the shift one. So that's gonna be height shift. And the color of the pixel is gonna be black, right? So fill screen, it's just gonna draw a black rectangle in here, right? So clear up whatever has been there. And after that, we just setting the cursor to 0, setting text size to 1, color to white, and then we print out the score. And this is it. This is really it. That should cover the score system for the Snake, and we should have entire game working right now. So I'm just gonna compile this code, deploy it, and we should see our Snake game completed. Okay, the game deployed, and now as we can see, we have a live score at the top left corner of the screen. Let me eat some food and score some points. As we can see, the value changed to 1, so we have 1 point now. 2 points. 3 points. So yeah, as you can see, essentially, the game is working now. So we have the full snake game with the live score on the top. If I, let's say I just finish the game, I got an extra information, your score below, game over, right? And the game starts again. Okay, cool. And this is it for today. Thanks for watching. Tomorrow I'm gonna show you how to scale the snake on the screen. So basically how to make it thicker, so it's gonna be easier to play. If you enjoyed this video, don't forget to subscribe to my channel. Thanks again and see you tomorrow.